Imagine a place so far from warmth that the sun becomes merely a star like any other, not a giver of heat, but only a distant point of pale light suspended in absolute black. Beyond Neptune's orbit, in the realm where planetary dominion yields to something stranger and older, there exists a region so vast and so quiet that it has spent 5 billion years barely disturbed. It is called the Kuiper belt, and it contains within it one of the solar system's most profound secrets. That silence itself can be beautiful, that cold can be gentle, and that the frozen edge of everything we know has been waiting all this time for us to simply listen. What would you discover if you journeyed past the last of the major planets, into a realm where objects drift in near-perfect stillness, their paths measured not in days or months, but in centuries, where the very concept of afternoon sunlight becomes laughably distant? The Kuiper belt is that place, and it offers lessons in calm that run deeper than almost anywhere else in our cosmic neighborhood. If you find yourself drawn to slow, science-based explorations of the quietest corners of our solar system, I invite you to subscribe. These journeys into the cold, the distant, and the perpetually patient edges of space have a way of helping the mind settle into its own kind of orbit. Now, imagine this. You are drifting outward from the sun's warmth. You have passed Mercury and Venus, left Earth's familiar blue circle far behind. You have moved beyond Mars, crossed the asteroid belt with its sparse dance of ancient stones, and now Neptune, that final blue-green sentinel, has itself become small, a remembered detail rather than a nearby world. And yet you continue deeper. The darkness grows not from fear but from distance. The sun, that burning disk that once filled the sky with gold and orange and the promise of heat, has become something else entirely. It is now an ember, not dying, never that, but reduced to its truest form, a luminous point, still burning with the fury of 1 billion hydrogen atoms fusing into helium every moment. Yet from here, from this vast remove, appearing almost modest, almost tender, the warmth that it radiates takes hours to reach you, and when it does, it carries so little energy that it barely registers as warmth at all. It is more a whisper of photons, a suggestion of heat rather than its substance. And all around you, in this space where the sun has become just another star, floats a realm of ice. The Kuiper belt is not a solid ring like Saturn's famous halo of bright particles. Rather, it is a zone, a region of space stretching from about 30 astronomical units from the sun to perhaps 50 or even beyond, and within it drift thousands upon thousands of icy bodies. Some are small, mere kilometers across, little more than floating mountains of frozen water and methane and rock. Others are larger. Pluto, that famous and controversial dwarf, moves through this region on its elongated path. Eris and Haumea and Makemake glide through the darkness on their own slow trajectories. And between them, in the vast spaces that make up the overwhelming majority of the belt, there is something that feels almost like silence. The cold here is absolute in a way that cold on Earth can never quite achieve, not because the temperature is necessarily lower than places like Antarctica or the upper atmosphere of Jupiter, but because there is so little substance here to warm or cool. A single hydrogen atom, perhaps another, might bump into you across hours. The vacuum is nearly perfect. The emptiness is almost complete. And in that emptiness, heat dissipates into nothing. There is no wind to carry warmth, no atmosphere to buffer it, no thermal mass to radiate it back. Cold is not imposed here so much as it is the natural condition of existence, the default state of matter when the sun's influence dwindles to an afterthought. This is the world beyond Neptune, a world that existed for more than 4.5 billion years before human eyes learned to perceive it. Long before telescopes, long before science itself, and even now, even after we have sent spacecraft and instruments to visit it, Much of the Kuiper belt remains profoundly unknown to us, profoundly untouched. The majority of its objects have never been observed by anything but gravity and time. They drift in their patterns, completing orbits that take centuries or millennia, their surfaces unchanged except for the infinitesimal weathering of cosmic radiation and the occasional nudge from a passing neighbor. What must it be like, you might wonder, to exist in such stillness, to move through a void at such a distance from the sun that the concept of a solar system, that gathering of planets around a central star, becomes a memory rather than a present reality? These frozen worlds do not know seasons, not in any traditional sense. They do not warm and cool with orbital position. They do not experience the rush of passing through clouds or the flash of atmospheric friction. They simply exist, suspended in their cold, their paths traced by the invisible mathematics of gravity, their surfaces reflecting the distant starlight with a dullness that speaks of their composition, ice and rock, and eons upon eons of patient waiting. The quietness of the Kuiper belt is not metaphorical. It is nearly absolute. There exists a particular form of peace in journeys like this one, excursions into the farthest, quietest corners of what we call our solar system, those realms where the sun has dwindled to merely another star in the blackness, where time itself seems to slow into something almost geological. And if you find yourself drawn to these whispered explorations of cosmic stillness, of the science that lives in the spaces between silence, then perhaps you might consider joining us in that journey. We create these long, patient narratives specifically for those quiet hours before sleep, documentaries woven entirely from real astronomical discovery, and the strange, soothing truths that emerge when we turn our attention outward to the edges of everything we know. Each episode unfolds slowly, with room for wondering, for the mind to settle into the rhythm of cosmic time. There is something deeply restful about learning the actual story of how these distant worlds were found, what they are made of, how they move through the darkness, according to laws that have held them steady for billions of years. If you wish to drift through more of these slow, science-based journeys, further out into the Kuiper belt perhaps, or deeper into the moons of the outer planets, or along the patient arc of cometary orbits, you will find them waiting, each one designed to carry you gently towards sleep, while teaching you something true and wondrous about the universe. The subscription exists for exactly this, to deepen that sense of cosmic peace, to make these narratives part of your regular rest. And now, let us return to that silence beyond Neptune, to the landscape we began to imagine, because there is much more to understand about what waits out there in the cold. The cold there is almost beyond comprehension, not the manageable cold of a winter night on Earth, not even the stinging, breathless cold of Antarctica's deepest valleys. At distances between 30 and 50 astronomical units from the Sun, that is, 30 to 50 times the Earth's distance from our star, the temperature hovers perpetually around -380 degrees Fahrenheit. In Kelvin, a unit astronomers whisper when they speak of the darkest places, it is roughly 50 degrees. A single degree of warmth would be a revolution there. The sun itself, from such a distance, appears not as the blazing disk we know, but as a pale, distant star, no brighter than Venus, appears from here, just another point of light against the infinite black. Imagine for a moment the quality of stillness in such a place. The vacuum surrounding these frozen worlds is not entirely empty. Nothing truly is, but it approaches emptiness with a patience that makes Earth's atmosphere seem almost impossibly thick and alive by comparison. Molecules drift here so rarely that a particle might travel for kilometers before meeting another. There is no wind, there is no sound, not in any sense we would recognize. The hiss and whisper and crackle of even the most remote desert on Earth would seem like a symphony compared to the silence here. It is a silence so complete it becomes almost tangible, a presence in itself, a soft weight that has settled over everything for billions of years. And in this cold, in this stillness, the worlds themselves move. But their motion, how do we describe it? It is not the eager hurrying of Mercury around the sun, racing its way through space in mere months. These bodies drift, they progress. They follow their orbital paths with the unhurried inevitability of continental drift, with the patient geometry of celestial mechanics that counts time in centuries and millennia rather than days. A Kuiper belt object might take 200, 300, even 400 years to complete a single orbit around the Sun. From any human perspective, from the vantage point of a single lifetime, they appear almost motionless, as if frozen in place, as if suspended in the deep dark like insects in ancient amber. The objects themselves, when our minds can hold their images, present a landscape alien and beautiful. These are not perfectly smooth spheres. They are irregular, tumbling gently through their slow pirouettes, some with companions that drift alongside them in gravitational embrace, couples dancing to music no one alive has heard. Their surfaces are painted in layers: methane ice, water ice, nitrogen frost, compounds that would be gases here on Earth, or at most thin liquids, but in that profound cold, they become permanent solids, the bedrock of distant worlds. Some may have thin atmospheres, gossamer envelopes of vapor clinging to their poles, barely deserving the name, but lending a hint of atmosphere to places that otherwise seem utterly barren. Consider the texture of such a place. Imagine running your hand, if you could wear a suit that would not shatter in such cold, across terrain that has not been significantly altered since the solar system's first dawn. There are no weather patterns to smooth the surface, no rain or wind or erosion in any sense we understand. The topography speaks of impact, of the ancient collisions that shaped these worlds billions of years ago, and of the slow sublimation of ices at their surfaces, the gradual transition of solid to vapor without any liquid intermediate, a process so leisurely it measured in molecules per century. There is a kind of timelessness to it, a sense of preservation that human consciousness can barely fathom. The darkness there is absolute for most hours. The sun is so distant that it provides no meaningful day and night, no rhythm of light and shadow. Instead, there is only the steady, unchanging ambient illumination from the stars themselves, from distant suns whose light has journeyed for years to arrive in that remote corner of our solar system. The Milky Way sprawls overhead, a river of ancient light flowing across the void, and that faint starlight is enough, barely, to distinguish the contours of the nearest worlds from the emptiness around them. This is the landscape where we now turn our attention. This is the realm of ice and patience, a realm that has waited, unchanged and unimagined by human consciousness, for most of our species' entire existence. And yet from within this ancient, cold, profound truths about our solar system's origins sleep quietly, waiting to be read by those patient enough to listen, to wait, to contemplate the unhurried dance of distant worlds beneath the pale and distant sun. And yet, long before any telescope could confirm it, long before astronomers possessed instruments sensitive enough to catch the faint glimmer of a distant ice world, two minds working in separate corners of the 20th century had already imagined this place into existence. They did not see it. They reasoned it into being, the way you might know someone is watching you from another room simply by understanding the shape of silence. Kenneth Edgeworth, an Irish astronomer, was thinking about the solar system's outer reaches in the 1930s. He noticed something that troubled him gently, the way a small inconsistency in an otherwise perfect piece of music might catch a musician's ear. Beyond Neptune, in that vast and seemingly empty gulf, the theory of planetary formation left questions unanswered. The solar system, he understood, had not simply assembled itself by accident. It had grown from a great swirling cloud of dust and gas, and the process by which planets emerged from that primordial haze suggested something curious. If planets could form where they existed, why should the region beyond Neptune be so barren? Why should such a vast expanse of space, so richly supplied with leftover material in the early solar system, remain completely empty? Edgeworth proposed a thought experiment, a quiet hypothesis whispered to a handful of colleagues. Perhaps, he suggested, the outer solar system had not been empty at all. Perhaps it was still full of objects, small, frozen bodies left over from the era of planetary formation. But they had never coalesced into large planets because they were spread too thinly, their gravity too weak to draw them together. These fragments, he imagined, would have remained there ever since, orbiting in profound quiet, unchanged, untouched, a frozen archive of the solar system's infancy. Few paid attention. The idea was elegant but unproven, and in those days, proof mattered more than elegant reasoning. The hypothesis drifted like a cloud that touches no ground, remaining in the realm of pure speculation. Edgeworth published his ideas, and the astronomical community read them with polite interest and moved on to other questions that seemed more immediately answerable. It was as though he had whispered a secret no one yet believed they needed to hear. Then, in the 1950s, more than a decade later, an astronomer named Gerard Kuiper had his own moment of geometric insight. Kuiper was studying the nature of comets, those mysterious visitors that appeared occasionally in Earth's night sky, trailing their brilliant tails. Where did they come from? No one knew for certain. Some comets seemed to arrive from the inner solar system, perturbed by planetary encounters, but others appeared to fall inward from directions that suggested origins far beyond Neptune's orbit. The mathematics and the observations both pointed to a place that should be full of icy bodies, yet no one had ever photographed one. Kuiper, working independently and apparently unaware of Edgeworth's earlier speculation, arrived at the same conclusion through a different path of reasoning. Beyond Neptune, he proposed, there must exist a vast population of icy objects. These were the source of the long-period comets, he suggested, the ones that took centuries or longer to circle the sun. His reasoning was sound, his mathematics rigorous, and when Kuiper published his work, it carried more weight in the astronomical community than Edgeworth's had. Still, it remained theoretical. Still, it waited for proof. The belt that would eventually bear Kuiper's name, though some astronomers insist it should honor both men equally, was imagined into clarity through thought alone. There was no observation, no direct detection, no image pulled from the night sky. There was only the quiet power of understanding how gravitational systems must behave, how the laws of physics and orbital mechanics suggested what kind of cosmic architecture would make sense in that distant region. Both Edgeworth and Kuiper were engaged in the same practice that has always driven astronomy, looking at the sky through the window, not of a telescope, but of mathematics and intuition and careful thought. For decades, their ideas remained beautiful speculations. The Kuiper belt existed only in equations and conversations among theoretical astronomers. It was a kingdom without subjects, a prediction without evidence, a name given to something invisible. And in that invisibility, in that patient waiting for confirmation, there lay a kind of restfulness. The idea could simply persist, undisturbed, for years and years, like an old story told softly around a fire that everyone found comforting, but no one yet needed to verify. The astronomers who pursued other questions, who looked for observable evidence of known objects, left this region in quiet peace. The Kuiper belt remained, in the minds of those who believed in it, as a calm presence just beyond the reach of proof, a patient hypothesis waiting for the night sky to whisper back. For nearly 60 years, the belt remained invisible, a phantom, a mathematical afterthought. Edgeworth and Kuiper had written their quiet theories into the astronomical journals, and the scientific community had filed them away like blueprints for a building that might never be constructed. The telescopes of the mid-20th century were powerful enough to see distant galaxies, to map the moons of Jupiter and Saturn, yet this ring of icy bodies circling at the edge of the sun's dominion, it simply could not be seen. And so astronomers went about their work, observing what was observable, cataloguing what was bright enough to catch their instruments' attention, while the Kuiper belt drifted on in its ancient, unhurried silence. Then came 1992, a night like 10,000 other nights at an observatory, unremarkable except for what it would reveal. A telescope in Hawaii, operated by astronomers David Jewett and Jane Liu, swept across the dark field of stars in the constellation Virgo. The equipment was good, but not extraordinary. The night was patient, and somewhere in the depths of that patient darkness, a small body, perhaps 300 kilometers across, made almost entirely of ice and frozen rock, crossed the sensitive detectors and left its trace. They named it 1992 QB1, a designation as spare and functional as the discovery itself. The name carried no poetry, no grandeur. It was simply a catalogue number, a way of saying, this object exists, we have found it, and it is real. But the implications that followed, those unfolded slowly, like a bloom opening across a very long afternoon. The object orbited beyond Neptune, exactly where theory had predicted such things might be. It moved through the darkness in patterns that matched the mathematics. It was, in its quiet way, an absolute vindication of decades of patient speculation. What happened next was perhaps more remarkable than the discovery itself. Other telescopes turned their gaze outward. Other astronomers began looking not for one object, but for many. And they found them. Dozens, then hundreds, then thousands. The belt revealed itself not in a sudden theatrical flourish, but in a gradual, accumulating crescendo of small discoveries. Each one added weight to the emerging understanding. Out there, beyond the orbit of Neptune, in a region of space so distant that sunlight reaches it as little more than a bright star, a vast congregation of icy worlds drifted in their slow, ancient dance. Jewett and Liu, in their 1993 discovery papers, described the phenomenon with the careful language of science, yet there was something almost breathless in their accounts. Imagine the moment. Imagine being an astronomer who had spent a career studying the solar system, who had learned the Standard Model, the 8 major planets, their moons, the asteroid belt between Mars and Jupiter, a few scattered comets, and then to realize that this model was incomplete, that an entire population of worlds, numbering in the hundreds of millions or possibly billions, had been waiting out there all along, invisible simply because they were small and distant and did not shine brightly. The astonishment rippled through the astronomical community. Telescopes that had been aimed in other directions were reoriented. Surveys that had been planned for other purposes were repurposed. Archives of old photographs, taken decades earlier, were carefully examined, and in those archives, astronomers found evidence. Other observatories, working in previous decades, had actually photographed Kuiper belt objects without realizing what they were looking at. The evidence had been there all along, scattered through the historical record like breadcrumbs, leading toward a destination that no one had yet recognized. This is perhaps one of the quietest and most profound confirmations in the history of modern astronomy. Not a sudden dramatic observation, not the discovery of a new planet announced with trumpet fanfares, the way Neptune's discovery had been celebrated in the 1840s, but rather a slow, patient vindication of mathematics and imagination. The theorists had imagined the belt into existence through pure reasoning. The observers had then discovered it through patient, methodical work, and in the years that followed, the picture would grow richer and deeper and more intricate, each new finding adding detail to what had once been merely a possibility. The discovery of 1992 QB1 represented something gentle but fundamental, the moment when the solar system revealed that it was larger, richer, and more complex than the previous generation had understood. And as that understanding grew, as telescope after telescope began to map this distant region, astronomers across the world felt something that might be described as wonder, but also something quieter, something closer to recognition. It was as if the solar system had been waiting patiently all along for humanity to finally notice what was there. And when that moment came, it arrived not with shock or disruption, but with the calm, inevitable quality of a truth that had always been true, simply waiting to be seen. And so what we are looking at, as this threshold becomes real and tangible through those early telescopes and patient surveys, is not a solid band, not a ring in the way Saturn wears its jewelry, but rather something far more subtle and dispersed. The Kuiper belt is, in essence, a vast region of primordial remnants, thousands upon thousands of icy bodies, leftover pieces from the solar system's infancy, scattered across an enormous arc of space that begins roughly where Neptune's orbit ends and extends outward for perhaps another 50 astronomical units or more, each one of those units being the distance from Earth to Sun. Imagine, if you will, the aftermath of creation itself, frozen in place and drifting in near-perfect stillness across billions of miles. These objects, these small worlds and moonlets and fragments, are composed largely of the substances that never coalesced into the 8 major planets: water ice, methane, ammonia, frozen nitrogen, and darker organic compounds that have remained largely unchanged since the solar system's earliest moments. They are, in a sense, time capsules, each one a preserved specimen of what the nebula was like 4.5 billion years ago, before gravity and collision and orbital mathematics reorganized the chaos into the orderly system we know today. The Kuiper belt represents, then, not chaos but rather the absence of chaos, a stable zone where these remnants have settled into long, unhurried orbits, cycling through the darkness in patterns that take centuries or sometimes millennia to complete. What makes this region so deeply fascinating, so worthy of contemplation in the quiet hours before sleep, is its profound stillness. Unlike the asteroid belt between Mars and Jupiter, which has been shaped by gravitational encounters and collisions into a relatively sparse field, the Kuiper belt maintains its objects in a kind of cosmic arrangement, some clustered in resonances with Neptune, others in more distant and solitary paths, all of them moving with a slowness that seems almost meditative when you consider the vast timescales involved. A single complete orbit around the Sun for many of these worlds takes longer than human civilization has existed. They have been traveling their paths in the darkness, unseen and unchanging, while entire ages rose and fell on Earth. The belt itself is not uniformly populated, a truth that astronomers have come to appreciate through patient observation. There are regions of greater density, particularly beyond Neptune's gravitational influence, where clusters of smaller bodies congregate, some of them perhaps only a few kilometers across, others as large as small planets. There are also vast stretches of emptiness, cold vacuum interrupted only by the faintest presence of dust and the occasional wandering stone. This distribution reflects something ancient and unchanging about how the solar system arranged itself, how gravity, in those earliest moments of formation, pulled certain materials into proximity while leaving other regions sparse and quiet. The Kuiper belt, then, is not one object or even a unified structure in the way we might imagine, but rather a collection, a slow drifting assembly of solitary worlds that share only their composition, their location, and their patient, unhurried journey through the void. What, you might wonder, makes these objects fundamentally different from the larger planets? Why did they remain small, frozen, and scattered rather than coalescing into something grander? The answer lies partly in distance. The farther from the Sun one travels, the slower material moves, the more attenuated the disk of debris becomes, and the less likely collisions are to occur. The solar nebula, in those long-ago moments of formation, was less densely populated in its outer reaches, and whatever material was present had so much space to occupy that gathering into planetary bodies became improbable. Yet improbable does not mean impossible, and the Kuiper belt does contain some substantial worlds, objects massive enough to be called planets by many definitions, even if official astronomy has chosen other labels for them. These larger bodies have left their mark on the belt's structure, their gravity creating subtle patterns, their own histories adding texture to the region's otherwise serene character. And here we find something profoundly calming in the thought. This belt has remained essentially unchanged for an incomprehensible span of time. The objects within it have orbited in their prescribed paths, generation after human generation passing without any alteration to their essential trajectories. No solar wind has stripped them bare, because so far from the sun's warmth, solar wind carries little power. No asteroid has fundamentally disrupted their arrangements, because the belt is so vast and so sparsely populated that collisions, while they certainly occur, are vanishingly rare events in cosmic terms. The Kuiper belt is, perhaps, the closest thing in our solar system to perfect, undisturbed rest, a region where time moves in long, slow cycles, where change happens on timescales so vast they might as well be eternity, where everything exists in a state of gentle, infinite patience. It is a place of absolute quiet, a repository of ancient memories locked in ice, and contemplating it offers something that the busier, warmer regions of our solar system cannot, a sense of profound, unchanging peace that invites the mind toward stillness, toward the kind of deep and undisturbed repose that waits for us in sleep. And yet, among all these ancient wanderers spinning in their distant orbits, one small world holds a place in the human imagination that defies its size. Pluto arrived in our consciousness quite suddenly, on the morning of February 18, 1930, when a young astronomer named Clyde Tombaugh, working at Lowell Observatory in Arizona, was examining photographic plates taken through a telescope, comparing images night after night, looking for the faint shift of movement that would reveal an undiscovered body. What he found was so faint, so distant, so improbable in its position that he could hardly believe it real. And yet there it was, a ninth planet, they called it then, the outermost sentinel of the solar system, and they named it after the Roman god of the underworld, which seems fitting somehow, a small dark world presiding over the realm beyond the sun's warmth. For decades, Pluto lived comfortably in that role, small though it was compared to the other planets, dimmer than even many moons. It orbited alone in the minds of school children, learning the orderly procession of worlds: Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, Pluto. 9. That was the number. That was the story we told. But Pluto was never quite like the others. Its orbit tilted at an unusual angle compared to the planetary plane. It moved in patterns that seemed almost independent, unswervingly devoted to its own ancient rhythm. And as decades passed and instruments grew more powerful, more curious objects began appearing in the Kuiper belt region, icy bodies of surprising size, some nearly as large as Pluto itself, others larger still. The question began to whisper through astronomical communities: if these worlds existed in such abundance beyond Neptune, what made Pluto special? What gave it the singular honor of planethood when thousands of its siblings remained unnamed and uncounted? The reclassification came in 2006, and it arrived with a gentleness that somehow made it more poignant. The International Astronomical Union, convening in Prague, carefully defined what a planet must be. It must orbit the Sun. It must possess enough mass to achieve hydrostatic equilibrium, to squeeze itself into a round shape through its own gravity. And it must have cleared its orbital neighborhood, becoming gravitationally dominant among all the bodies near its path. Pluto satisfied two of these criteria perfectly, but the third condition, that demand for orbital dominance, revealed Pluto's true nature. It shares its orbital zone with thousands of other icy bodies. It has not swept its neighborhood clean. And so, with a decision that felt almost like a quiet admission of truth, Pluto was reclassified. No longer a planet. Now a dwarf planet. Now a Plutino, one of many, though still among the most substantial. Imagine how that might feel, if one could feel, to be redefined, to lose a title held for 76 years. And yet there is something almost restful in that reclassification, something that returns Pluto to its true nature. It is no longer asked to stand apart, to be exceptional in a way that perhaps never suited it. It returned home, in a sense. It became what it had always been, a resident of the Kuiper belt, a keeper of the ancient ice, a fossil from the solar system's infancy. And in that reclassification, something paradoxical occurred. Pluto became more interesting, not less. Released from the burden of planetary status, it became more free to simply be itself. Mysterious, ancient, patient, and utterly enigmatic. In the years since that redefinition, Pluto has been observed with a kind of renewed affection. There is something humanly appealing in a thing that was thought important for so long, and then discovered to be different than expected, yet no less worthy of our attention. Every astronomer who looks toward Pluto's distant orbit seems to carry a small understanding of what it means to be reconsidered, to be redefined by the rest of the world, and yet to retain an inherent quiet dignity regardless of what category the taxonomy might place you in. Pluto continues its patient orbit, unmoved by our reclassifications, untroubled by our changing definitions. It was there long before we named it. It will be there long after our words have ceased to matter. The ice upon its surface gathers the ancient cold. The shadows of its mountains stretch across a terrain no human eye will ever see except through images captured by distant machines. And perhaps that is the deepest rest of all, to be freed from expectation, to orbit in silence, to simply exist as you truly are in the vast patient dark. And so while astronomers continued their patient cataloguing of this newfound realm, humanity decided to send a messenger. In the year 2006, on a January morning when the world was still mostly sleeping, a small spacecraft called New Horizons lifted away from Earth on a trajectory that would carry it farther from home than any human-made object had ever traveled with purpose and deliberation. Its destination, Pluto, that small, dignified dweller at the edge of everything known and beyond. The journey would take 9.5 years. 9.5 years of drifting through the void, through solar wind and starlight, through zones of space where the sun's warmth fades to almost nothing, where the temperature hovers just above absolute zero. The spacecraft was small enough to hold in your hand, yet it carried within itself humanity's most sophisticated instruments for seeing, for measuring, for touching the unknown from a distance. It moved at 36,000 miles per hour, and yet this velocity, this almost inconceivable speed, rendered the distances so immense that it still needed a decade to complete its crossing. Imagine, if you can, the quality of that journey. The spacecraft did not race. It drifted, in a sense, following a path through space that the laws of physics had already written long before its departure. There was no urgency in its motion, no frantic haste. It was a voyage of pure patience, a meditation made manifest in metal and silicon and light. Year after year, it moved deeper into the twilight, past the orbits of Mars and Jupiter, past Saturn with its ancient rings, past the cloudscapes of Uranus and Neptune with their restless methane storms. And with each passing month, the sun grew smaller, not retreating so much as dimming, like a fire viewed from ever greater distances. The quiet of that journey was absolute. There is a profound stillness in traveling through the space between worlds. Radio signals from Earth, traveling at the speed of light itself, took hours to reach the spacecraft, and hours more to return with replies. Communication with New Horizons became, by necessity, a slow conversation, a patient exchange of information across a gulf so vast that simultaneity itself became impossible. Mission controllers could not command the spacecraft in real time. Instead, they sent their instructions into the darkness and waited. The spacecraft, in its solitude, had to be trusted to follow its path, to measure what it encountered, to record and remember. As it journeyed, New Horizons passed through a realm of near vacuum, quieter than anything most of us will ever truly comprehend. This is not the vacuum of laboratories on Earth, which is still quite crowded by comparison. This is the vacuum of space itself, where individual atoms and particles are so few and far between that you might travel for miles without encountering another speck of matter. The spacecraft's instruments could feel the solar wind, that thin stream of charged particles flowing out from the sun like an invisible breath, growing fainter with distance. In this environment, there was almost nothing to disturb the spacecraft's serene progression. No collisions, no turbulence, no sound. For sound itself cannot exist where there is neither matter nor atmosphere to carry it. There was, perhaps, a profound beauty in this loneliness, though the spacecraft could not have appreciated it. For its creators and followers on Earth, however, there was something deeply moving in knowing that this small machine, built with such care and intelligence, was faithfully making its way through one of the most remote and cold regions of the solar system, carrying humanity's curiosity like a small, persistent light. The engineers and scientists who had built it had already grown old. Some had already passed away, yet the machine they had crafted continued on, faithful to its purpose, unwavering. The approach to Pluto began, in a sense, almost imperceptibly. New Horizons was still months away when it began to sense the presence of its destination. The spacecraft's instruments could detect the faint pull of Pluto's gravity, could measure the thin exosphere that leaks away from that distant world into the surrounding cold. The spacecraft began to transmit images, first grainy and small, then gradually growing clearer as the distance narrowed. On Earth, astronomers leaned toward their monitors in the dim light of observation rooms, watching as a world that had been merely a point of light for 85 years began, finally, to reveal itself as a place, as somewhere real, with topography and texture, with geology that had been hidden since before any human eyes had learned to look beyond our own sky. The anticipation of that moment, as New Horizons closed the final distance, was itself a kind of meditation. The spacecraft could not rush. The laws of physics would not permit acceleration at this scale. All that could be done was to maintain the trajectory, to keep the instruments calibrated and ready, to wait. And waiting, in the context of this vast cosmic journey, felt like the most natural thing in the universe. It felt, almost, like rest. And so on that July morning in 2015, after 9.5 years of patient flight through the void, New Horizons drew near to the world it had been sent to meet. The images that began to arrive, transmitted back across 3 billion miles of silence at the speed of light, taking 4.5 hours to cross that distance, showed something that no human eye had ever truly witnessed before. Pluto revealed itself not as the vague, grainy disk of earlier telescopic studies, but as a world of striking, impossible beauty. The spacecraft had been aimed to pass within 7,800 miles of the surface, a whisper away in cosmic terms, and as it approached, the frozen sphere began to unfold its secrets, with a gentleness that seemed almost deliberate. The first surprise was the sheer complexity of what lay on Pluto's surface. There were mountains of water ice towering thousands of feet high, their slopes so pristine and sharp they seemed almost sculptural, as if carved by an artist's careful hand rather than shaped by billions of years of geological processes. These ice mountains caught the distant sunlight, that same sunlight that had dwindled to little more than a bright star at this distance, and cast the gentlest of shadows across the frozen terrain. And there, sprawling across the western hemisphere like a great heart, lay what would come to be called Tombor Regio, a vast, peculiar plain of what appeared to be nitrogen ice and methane ice, smooth and young in its appearance, almost serene. The lighter regions within it seemed to glow with a quiet luminescence, their surfaces unmarked by the ancient cratering that covered so much of Pluto's older regions. What drew the breath from astronomers studying these images was not merely the detail, but the profound sense of a world that had not yet finished telling its story. The nitrogen ice plains suggested ongoing geological activity, slow and subtle, though it must be at temperatures approaching 400 degrees below 0 Fahrenheit. There was, perhaps, internal heat still rising from Pluto's depths, still reshaping its face in ways that the scientists had not anticipated. Or perhaps these were simply the last vestiges of ancient activity, patterns frozen into place from Pluto's younger days when it possessed more internal warmth. The distinction between these possibilities mattered less in those first moments of wonder than the simple fact of discovery itself, the recognition that this distant world was far more dynamic and intricate than anyone had dared suppose. The images also revealed something hazier, more ethereal. Around Pluto hung what appeared to be a thin atmosphere, a whisper of existence at the edge of having any atmosphere at all. This was methane and nitrogen frost, evaporated from the surface by the faint warmth of the distant sun, forming layers of floating ice crystals and delicate haze that caught the light in ways that seemed almost dreamlike. The haze clung to the limb of Pluto, its edge where light and shadow met, creating a pale, luminous outline that gave the dwarf planet an unexpected gentleness. What would you expect from such a world so far from the sun, where the air itself would be perpetually on the edge of condensing into ice? Yet here it was, this gossamer presence, a reminder that even at the frozen frontier of our solar system, there is still movement, still change, still the whisper of activity. As the spacecraft slipped past the dwarf planet, swinging through its gravitational embrace, the images kept arriving in steady streams. High-resolution photographs emerged of Pluto's smaller moon Charon, which had been a mystery for decades. Charon appeared equally strange, equally wondrous, a world of massive canyons and cliffs, its south pole stained with a dark material of unknown composition, perhaps organic molecules created by the interaction of solar radiation with simpler ices. The connection between Pluto and Charon, their eternal dance around their shared center of gravity, seemed to deepen in meaning as the photographs multiplied. They were partners in this distant realm, locked together in an embrace that had endured for billions of years, and they were revealing themselves, at last, to the distant watchers back on Earth. There was something profoundly moving about these images, something that touched on feelings deeper than mere scientific curiosity. The photographs had been anticipated, prepared for, hoped for, across decades of planning and 9.5 years of waiting, yet they still arrived as a kind of grace. Here was a world that had never been seen clearly before, that would never be approached again by human technology in any conceivable future, showing itself in these brief moments with a quiet dignity. The haze floated, the ice gleamed, the ancient surface told its slow story. And in laboratories and observatories across Earth, scientists wept and marveled at the unveiling of a truth that had been hidden since the solar system's infancy. The hush that fell over the community was not one of disappointment, but of reverence, the kind of deep, peaceful recognition that comes when the universe opens itself to our gaze, if only for a moment, and we are allowed to see it truly. And yet there remained one more gentle revelation waiting in the darkness beyond Pluto, a thing so strange and beautiful that when New Horizons finally found it, spinning slowly through the deep cold of that ancient realm, the scientists aboard could hardly believe what their instruments were showing them. They had aimed for a second encounter, a smaller world, a distant object catalogued merely as 2014 MU69, though in time it would be given a far more poetic name, Arakoth, which means sky in the Powhatan language, a sky that perhaps no human eye was meant to witness until this very moment. What makes Arakoth so remarkable, so deeply and persistently remarkable, is its shape. Imagine, if you can, a cosmic snowman crafted by the gentlest hand imaginable. Two lobes, two soft rounded bodies pressed together at a narrow neck, creating a form that astronomers gently call a contact binary. Two separate bodies that have been slowly, patiently orbiting one another for so long that gravity drew them into an embrace, and there they have remained, spinning together in absolute silence. The larger lobe extends about 12 miles across, the smaller perhaps 9, and the entire structure rotates with such leisurely grace that a single rotation takes 10.5 hours, making Arakoth one of the slowest spinning objects known in the solar system. Even the word rotation feels too active for something that turns with such profound, unhurried deliberation. When New Horizons sent back its first clear images in January of 2019, 3 years after that momentous Pluto flyby, what the scientists saw was not the rough, cratered surface they might have expected from a billion-year-old wanderer of space, but rather something altogether softer, something that seemed almost unbroken, almost untouched. There are craters, yes, but they are few and gentle, as though this small world has been spared the endless bombardment that has scarred so many other bodies in the solar system. The surfaces are smooth in places, sculpted by some process, or perhaps preserved by some merciful cosmic accident into a state of quiet dignity. The leading hemisphere, the side that faces forward as Arakoth continues its ancient orbit, carries what appear to be gentle hills and ridges, subtle undulations of terrain that rise and fall with remarkable quietness. The equator, that invisible line running between the two lobes, has collected what seems to be finer material, small particles that may have drifted inward over immense stretches of time, and this creates bands of slightly different color and texture, hints of a slow and patient reorganization of surface features. The color itself is a study in subdued tones, reddish-brown in some places, a cold grey in others, as though Arakoth has been gently tinted by the faint touch of cosmic rays and the slow chemistry of ice and dust meeting one another over billions of years. What is perhaps most extraordinary is what Arakoth tells us about the very beginning of the solar system itself. This object, so distant, so cold, so pristine in its preservation, may very well be a relic, a fossil of sorts, from that turbulent epoch when the sun had just ignited and the great planets were still settling into their orbits. The theory suggests that Arakoth was not formed by violent collisions or aggressive mergers, but rather through a process almost gentle by comparison, a process called pebble accretion, where countless tiny particles, drifting through the primordial solar nebula, came together in a slow, gravitational waltz, gathering gradually, layer upon layer, building up mass through patient accumulation rather than cataclysmic impact. This means that the two lobes of Arakoth, those two softly rounded bodies that now spin together, may have formed separately in slightly different regions of the early solar system before drifting slowly toward one another and being captured by their mutual gravity into this tender embrace. For billions of years since that gentle collision, they have remained locked together, undisturbed, rotating as one, accumulating almost no new craters, almost no new scars. The solar system has changed dramatically around them. Planets have shifted their orbits. The sun has aged and grown hotter by infinitesimal degrees. Comets have come and gone, burning briefly in the warmth of the inner solar system. Yet Arakoth has spun on, unchanged, unaltered, a memory made solid. And here is where the quietness of Arakoth becomes almost haunting in its beauty. This small world, This gentle two-lobed shape drifting through the cold has remained so undisturbed, so preserved in a kind of cosmic stasis that it offers us something almost unique, a glimpse not only of what the early solar system may have looked like, but also of what the solar system wanted to create, before the great chaos and sorting gave way to the orderly, if violent, universe we know today, where Jupiter's moons are cratered and scarred, where asteroids have been broken and scattered, where rocky planets have been reshaped by impacts and thermal evolution. Arakoth sits serenely, a question asked in ice, and asking us in turn whether the universe, given the chance and the distance from the violent inner regions of space, might not prefer a gentler form of being. The darkness that surrounds Arakoth at its orbital distance is almost total, the sunlight having diminished to the faintest of amber glows, a bare glow sufficient to give New Horizons the tiny amount of reflected photons it needed to see and to photograph this distant stranger. And in that minimal light, in that careful observation of a world that had remained unknown for the entire history of human civilization until this very recent moment, there is something profoundly soothing about the realization that this gentle shape, this soft double globe, has been circling quietly all this time, asking nothing, changing nothing, simply existing in the deep and patient cold, a frozen fossil from the solar system's earliest and gentlest days. The surfaces of these frozen worlds are not uniform, not simple sheets of ancient ice. They are instead composed of a delicate chemistry, a layered tapestry of substances that formed in the cold dark of the solar system's infancy and have remained largely unchanged ever since. Water ice, the most abundant of these frozen elements, covers much of what we have observed in the Kuiper belt. It is the same substance that fills comets and caps our own polar regions. Yet here, at these extraordinary distances from the sun, it has a different character altogether. It does not melt, it does not flow, it simply persists, hard and still as stone, locked in its crystalline silence for billions of years. But water ice alone does not tell the full story of these sleeping worlds. Mixed within and across these icy surfaces lies methane frost, a thin, delicate layer that gives the Kuiper belt its peculiar and quieting beauty. Methane, the same gas that rises from swamps and dairy farms on Earth, exists here in solid form. It is one of the most volatile substances present on these distant bodies, yet volatility in this context takes on an almost philosophical quality. To be volatile here means something entirely different than it does in the warmth of our world. The surface temperatures of Pluto and its neighbors hover near -380 degrees Fahrenheit. At such temperatures, methane becomes as hard and permanent as granite. It is locked in place. It will not evaporate quickly. It might take millions of years for a single molecule of methane frost to escape into space, and even then, only if a cosmic ray strikes it or if it drifts toward the sun in some distant age to come. Nitrogen frost adds another layer to this chemical stillness. The mountains of Pluto itself are not made of rock, or at least not primarily. Many of them are composed of nitrogen ice compressed and shaped by the world's slow internal forces. Nitrogen ice is even more unusual than methane. Here, in our solar system's warm interior, nitrogen exists as a gas, the very air we breathe. But in the Kuiper belt, it becomes something crystalline and heavy and patient. The vast nitrogen plains near Pluto's equator, the ones that New Horizons glimpsed in 2015, are relatively young geological features, comparatively soft and smooth. They suggest that nitrogen ice can still move, still deform, still respond to the faintest internal heat sources that persist within these ancient bodies. This discovery was quietly astonishing because it suggested that these worlds are not entirely frozen and dead. There is still something happening, still a faint heartbeat of activity in their interiors. Yet the sunlight that reaches these surfaces is so dim, so terribly faint, that one might almost say there is no warming at all. The sun, from the perspective of the Kuiper belt, is no longer the bright disk we know in our sky. It is simply one more star among many. No more prominent than Venus or Jupiter appears to our naked eye on a clear night. The energy that reaches these distant worlds is diluted across the vast intervening space, reduced to a whisper of radiation. This means that the heat budget of the Kuiper belt is almost entirely determined by other sources. The residual warmth left over from the solar system's formation, the occasional collision between objects, the slow decay of radioactive elements buried within these icy bodies. The idea is profound and quieting. These worlds are cold not simply because they are far from the sun, but because the sun's voice, so powerful in our inner solar system, has become nearly inaudible by the time it reaches them. The surfaces themselves reflect what little light does arrive. The water ice and methane frost and nitrogen plains act like mirrors, sending much of that faint sunlight back toward the stars. In some ways, this makes the Kuiper belt self-effacing. These are worlds that do not absorb the sun's attention. They exist in a state of gentle independence from the heat that drives so much of what happens in the inner planets. Consider the difference between Earth and Pluto. Earth's surface temperature is modulated by the sun's energy. Our seasons change. Our ice caps advance and retreat. Our weather is driven fundamentally by solar input. Pluto, by contrast, operates on a timescale so different that the sun's current output is almost irrelevant to its present condition. The methane frost that covers its heart was laid down millions of years ago. The nitrogen plains are only slowly evolving. The water ice mountains are essentially unchanging. They are in deep sleep, and that sleep is so profound, so complete, that even the presence of the sun feels like a distant rumor. The chemistry of these icy surfaces also tells us something about the early solar system, about the state of elements when the sun was young, and the disk of dust and gas that surrounded it was settling into order. Methane, nitrogen, and water ice all condense at the cold temperatures that exist beyond the orbit of Neptune. In the hot inner solar system, these substances would never collect into solid form. They would remain as gases, drifting away into space, or remaining dissolved in other materials. But here, in the quiet outer reaches, they accumulated and froze and stayed frozen. In a very real sense, the Kuiper belt is a deep freezer, a preservation chamber for the oldest and simplest materials of our cosmic neighborhood. When we study the ice chemistry there, we are looking backward in time, reading an ancient record written in frozen compounds that have changed little since the solar system itself was young. What is perhaps most relaxing about this chemistry, most quieting in the contemplation of it, is the sheer stability of these frozen forms. Unlike the dynamic weather and climate of Earth, unlike the violent chemical reactions that occur in the sun's photosphere or the roiling atmospheres of gas giants, the ice chemistry of the Kuiper belt is static. It is patient. It asks nothing of us and offers only the gentle knowledge that there exist places so cold, so distant, so removed from the fierce activity of the sun, that molecules can remain essentially unchanged for the entire history of human civilization, for the rise and fall of empires, for the birth and death of stars. The methane frost will still be there in 10,000 years. The nitrogen plains will remain, slowly rearranging themselves through processes we are only beginning to understand. The water ice mountains will endure. This permanence, this quiet chemical fidelity to the ancient past, is perhaps one of the most soothing thoughts available to the contemplative mind. The objects in the Kuiper belt do not rush. They have nowhere to go, and they have forever to get there. Each world moves along its own path, an ellipse so wide, so gently stretched across the solar system's outer edge, that the journey from closest approach to farthest retreat can take 200 years, or 300, or longer still. A single orbit, a single complete circuit around the sun, measured not in days or months, as we count them on Earth, but in centuries that span entire human histories. Consider for a moment what that means. When a Kuiper belt object reaches its nearest point to the sun, the photographer who watched it approach may have lived an entire lifetime before it swings back again. Civilizations may rise and fall, yet the object continues its stately path, indifferent to time as we experience it. The rhythm of these orbits is geology's rhythm, not the rhythm of the human heart. Now imagine, if you will, the deeper choreography that governs this place. Neptune sits at the inner edge of the belt's neighborhood, a gravitational monarch whose influence ripples outward through the cold. And the objects of the Kuiper belt do not orbit randomly. Many of them move in patterns called resonances, mathematical relationships where their orbital periods bear a precise ratio to Neptune's own. Two objects might complete one orbit around the Sun in the time that Neptune completes three. Three might orbit while Neptune orbits 4 times. These are not coincidences. They are the fingerprints of an ancient gravitational waltz, a memory of how the solar system was shaped and rearranged in its violent youth. The most famous of these resonances is the 2 to 3 resonance, sometimes called the Plutino zone, because Pluto itself dances in exactly this pattern. Every 2 times Pluto orbits the Sun, Neptune orbits exactly 3 times. This relationship keeps Pluto safe. It prevents the two worlds from drawing too close, colliding in some catastrophic encounter that might have scattered them both across the void. Instead, they maintain their distance, synchronized by gravity, in a rhythm as old as the solar system itself. It is a kind of cosmic stability, a gentle enforcement of order. And throughout the Kuiper belt, hundreds of thousands of objects follow similar patterns. Some dance in the 3 to 5 resonance, others in the 4 to 7. The belt is not a chaotic realm, despite its distance and cold. It is structured. It follows rules written by gravity and time, and those rules have been inscribed for over 4 billion years. What draws the mind into contemplation is how slowly these dances play out. The orbital period is so vast that observing these resonances requires human astronomers to watch the same objects across decades of careful tracking. We take a snapshot, we wait, we take another, and slowly, over years of patient observation, the pattern reveals itself. It is detective work, conducted in slow motion. It is the unfolding of mysteries that move at a pace that almost seems to invite stillness, as if the Kuiper belt itself is inviting us to slow down and watch carefully. The spacing of these resonances is also not random. When gravity shapes a system over such immense timescales, the spaces between orbits tend to empty out. Objects in unstable orbits are gradually nudged away by gravitational perturbations, little by little, over millions of years. What remains are the safe zones, the resonant families, where countless smaller worlds cluster. The gaps between these zones tend to fill with fewer objects. It is a form of sorting, a settling out of order from chaos, as if the Kuiper belt were a slow sediment, finding its level across eons. This is where Eris dwell, in the scattered disk region, where orbits become more erratic and elongated, where objects stray farther from the plane of the solar system. And yet, even there, the gentle hand of resonance can be felt. Eris itself moves in a 7 to 12 resonance with Neptune, though it ventures far beyond the classical belt's boundaries. It is another testimony to the persistence of pattern, to the way gravity enforces relationship across distances so vast they seem incomprehensible. One might ask, does this rhythm continue forever? The answer, surprisingly, is no. The orbits of Kuiper belt objects are not immutable. Over spans of time, even longer than the age of the solar system itself, gravitational interactions, tiny, subtle influences between the multitude of objects, gradually accumulate. An orbit that is stable for billions of years may eventually shift, but at the scale of observation available to us, the belt appears eternal. It has the quality of permanence. There is something profoundly restful in the contemplation of such motion. Human life is governed by cycles of urgency, the beat of the heart, the round of the day, the turning of the seasons. But here, at the edge of the sun's domain, cycles span longer than human memory. A Kuiper belt object need never hurry. It will complete its orbit at precisely the pace set by gravity and inertia, following paths so predictable that astronomers can calculate their positions centuries into the future. There is a kind of peace in such inevitability, a kind of assurance that the universe operates according to deep, unchanging rules. That motion itself, when stretched across time enough, becomes almost indistinguishable from rest. Beyond Pluto, in the dimmer reaches where sunlight becomes merely a memory, other worlds turn in their separate solitudes. Each one possesses its own character, its own story written in ice and ancient dust, waiting patiently across the vast stretches of time for anyone curious enough to know them. There is Eris, a world so distant that it spends more than 5 centuries completing a single orbit around the Sun. When astronomers first detected Eris in 2005, they recognized immediately that this frozen wanderer was slightly smaller than Pluto, yet somehow heavier, denser, as though it had collected more of the solar system's ancient material into its frame. Imagine holding 2 pieces of ice in your hands, one appearing larger but lighter than the other. This is the nature of Eris. Its surface lies beneath a thick coating of frozen methane and nitrogen, materials so volatile that they remain solid only in the profound cold of that distant realm. The world tilts at a severe angle, as though it has been tilted over on its side long ago, and if there were an observer standing on its landscape, the sun would appear as scarcely more than the brightest star, casting shadows of an ethereal, subtle clarity. What renders Eris particularly fascinating is the way it dances with Neptune's gravity from afar, not in any dramatic fashion, but in a gentle mathematical harmony, a resonance that astronomers describe using numbers and ratios. For every 11 times Neptune circles the Sun, Eris traces out exactly 5 of its own vast paths. There is something restful in contemplating such rhythms, such orderly patterns persisting across millennia. The world orbits in a manner that carries it far beyond the traditional boundary of the Kuiper belt, into a region sometimes called the scattered disk, where objects drift in solitary, elongated paths like leaves on a vast, slow current. Makemake glides through its own quieter corner of this distant realm. Smaller than Pluto and Eris, yet still a world of consequence, Makemake presents itself to the universe with a surface rich in frozen methane and ethane. Where Eris appears shrouded in nitrogen frost, Makemake wears its methane coating with the cool elegance of something carved from the oldest reaches of stone and ice. Its name, given by those who study these worlds, derives from the creation mythology of the Rapa Nui people, the creators of the stone figures on Easter Island, a naming choice that seems fitting for a world so ancient and enigmatic. Makemake's surface displays subtle variations in brightness, suggesting regions of different composition or different ages, though no spacecraft has ventured so far to confirm what these differences truly are. The world remains, for now, a whisper of information gathered by distant light, by the subtle shift of wavelengths as it drifts. Then there is Haumea, a world of peculiar geometry. Rather than the nearly spherical forms that dominate much of the solar system, Haumea stretches and bulges, shaped like a gently spinning egg or an elongated ellipse. How did it achieve such a shape? The most likely answer emerges from a collision in the distant past, perhaps billions of years ago, when this world encountered another body of substantial size. That impact did not destroy Haumea, but it set the world spinning with tremendous speed, far faster than most objects in the solar system rotate. The rapid rotation causes the world to bulge outward at its equator, like a spinning top that widens and flattens as it turns. Haumea completes one full rotation in approximately 4 hours, a rhythm that feels almost quick when compared to the glacial orbits these worlds undertake. Its surface, too, consists primarily of water ice, but this ice carries itself with a brightness that suggests a relatively young surface, perhaps refreshed or reworked by some process that remains partially mysterious. Around Haumea, at least 2 small moons orbit in their own careful paths. These companions trace out their elliptical routes with the same patient persistence as Haumea itself traces its journey through the solar system. There is something tender about imagining these small worlds held in gravitational embrace, circling one another across the centuries in a dance choreographed by laws of motion established at the very beginning of creation. Each of these worlds, Eris with its profound distance and ancient rhythms, Makemake with its methane veil, Haumea with its strange, egg-like form, represents a fragment of the solar system's earliest days. They are not merely cold rocks floating in emptiness. They are archives, repositories of material that has remained largely unchanged for 4.5 billion years. Within their ices are preserved chemicals and structures that speak to conditions that prevailed when the sun itself was young and the planets were still settling into their eventual orbits. To contemplate these worlds is, in a sense, to contemplate the memory of creation itself, held in silent suspension at the edge of all things we know. The light from the sun, when it reaches these distant bodies, reflects back toward us, carrying information across the immense gulf of space and time. What we perceive in that faint reflected glow is a story of patience, of slow transformation, and of worlds that ask nothing of the universe but to follow their prescribed paths through the vast darkness. They do not rage or burn, they do not collide or dance in dramatic fashion. They simply persist, circling, waiting, frozen in their appointed courses, as they have done through all of human history and will continue to do for ages to come. And yet the Kuiper belt is not entirely still, not entirely at rest. Deep within its frozen expanse, something stirs now and then, something that begins an ancient journey none of these distant worlds ever complete. Some of these icy bodies, drifters, wanderers, loose remnants that have never fully settled into the quiet rhythms of the belt, begin, very slowly, to fall. Not to fall catastrophically, but to drift, to begin the long, inexorable drift inward, pulled by the immense gravity of the sun at the center of all things, a pull so gradual that it may take thousands of years, or tens of thousands, for such a body to move perceptibly closer to the solar furnace. And as this happens, as these ancient chunks of ice and dust inch their way toward the warmer regions of space, they transform. They begin to reveal themselves. They become what we know, what we have always known, as comets. A comet is something rather extraordinary when you think about it. It is a Kuiper belt object, essentially, a frozen relic from the solar system's infancy that has been touched by proximity to the sun's warmth and begins, almost reluctantly, to awaken. The sun's radiation, even at the vast distances of the outer solar system, begins to vaporize the volatile ices locked within these wandering bodies. And as they vaporize, they escape into the vacuum of space, carrying dust and particles with them, creating that luminous tail that has captivated human observers for millennia. That beautiful, eerie tail is not smoke, not in any conventional sense. It is the very substance of the comet itself, boiling away into space, a slow dissolution in the face of the sun's persistent energy. For thousands of years, perhaps longer, a comet that has begun this inward drift will approach the inner solar system, glowing brighter as it comes, its tail growing more impressive, more haunting. It becomes visible to the naked eye. It becomes a celestial event, something that commands attention, that stirs wonder and, in ages past, fear. And then, for a brief time, a few weeks, perhaps a few months, it graces the night sky of Earth and the other inner planets with its presence. It is a visitor, a guest from the deep frontier, a messenger from that vast, quiet realm of frozen silence. And then, almost as quickly as it arrived, it retreats. It continues on its orbital path, and once again it drifts back out into the cold, the darkness, the long sleep of the outer solar system. Some comets, if they survive the journey, if they do not vaporize entirely or collide with the sun or a planet, will eventually return to the Kuiper belt. Others will take so long to complete their orbits, perhaps centuries, perhaps millions of years, that when they return, if they return at all, it will be so far in the future that it will be as if they are new comets entirely. Consider for a moment what this means. The comets we see from Earth, the bright visitors that appear unexpectedly and vanish just as mysteriously, these are Kuiper belt objects. They are pieces of that distant world, the ancient frozen world that orbits so far from the sun that we can barely perceive it. We cannot see them in the belt itself. They are too small, too distant, too dark. But when they venture inward, when they drift into the realm of warmth and radiation, we see them. We are witnessing, in a sense, the rare occasions when the Kuiper belt chooses to reveal itself to us. When it sends a small portion of itself on a visitor's journey to the inner solar system, there is something deeply poignant about this. The Kuiper belt is so vast, so patient, so removed from the bustle and light of the sun's nearest domains. And yet it is not completely isolated. It is not truly separate. It is connected to the inner solar system, to Earth, to us, through these slow migrations of ice and ancient matter. When you look up at a comet in the night sky, you are seeing a fragment of that frozen frontier. You are seeing evidence of the connection between our warm, bright neighborhood and that vast, cold, quiet realm billions of miles distant. And you are witnessing a journey that has taken millennia to unfold, that will take millennia more to complete. The mechanisms that launch these Kuiper belt objects toward the sun remain, in many ways, subtle and not entirely understood. We know that gravitational perturbations, the gentle nudges of passing stars, the complex resonances of planetary orbits, the slow shifting of the sun's gravitational field as the galaxy turns, can, over immense timescales, knock a wanderer slightly off its path. A nudge here, a slow drift there, and eventually an object that has remained in the belt for billions of years finds itself pulled inward. The process is never violent, or rarely so. It is the universe's way of moving at its own pace, operating on a scale of time so vast that we can barely imagine it. To a comet beginning its inward journey, the shift from deep belt solitude to inner system visibility is not an event. It is a long, slow awakening. And when that awakening occurs, when a comet enters the realm of the sun's more direct influence, something else happens. The heat does not merely cause the ice to sublime, to transform directly from solid to gas. It does something more subtle. It causes the comet to brighten, to become visible, and in doing so, it tells us a story. The story of the Kuiper belt, the story of solar system formation, the story of ancient cold and ancient patience. Every comet is a message from that distant world, written in ice and dust, a message that travels across the vast emptiness of space and arrives here, in our night sky, for a brief, brilliant moment. And then the comet continues on its way, carrying that same message back out into the darkness, to wait in silence for the next visitor from Earth's perspective to make the journey inward, to make the slow, ancient pilgrimage from cold to warmth and then back again to cold. To understand the Kuiper belt is to hold in your mind an image of the solar system being born 4.5 billion years ago from a vast cloud of gas and dust so immense that it dwarfed everything we see today. This cloud, what astronomers call the solar nebula, was not a violent explosion, as the word nebula might suggest, but rather a slow, patient collapse. Gravity, gentle and insistent, drew the particles inward, and as they fell toward the center, friction warmed them, and the whole disk began to spin. Picture, if you can, the young sun igniting at the heart of this spinning disk. Around it, in those first million years, solid grains of dust began to clump together. Pebbles formed from dust, rocks formed from pebbles, asteroids formed from rocks, and planets formed from asteroids, each one growing heavier, warmer, and more restless as it accreted more and more material from its orbit. The inner solar system, close to the heat of the newborn sun, became a realm of rocky worlds. But further out, where the sun's warmth barely reached, something different was happening. Ice could survive, ice thrived. The question that planetary scientists have pondered for decades, and continue to ponder, is this: how did the Kuiper belt come to contain so much pristine, ancient material when everything else in the solar system seems to have been stirred, collided, heated, and transformed? The answer lies in a concept that researchers call the Grand Tack, a theory that paints a remarkable picture of planetary migration and cosmic rearrangement. In the beginning, Jupiter, the solar system's largest planet, likely formed much closer to the Sun than it orbits today. Saturn formed nearby as well. According to the migration model, Jupiter gradually drifted inward over millions of years, pulled by gravitational interactions with the disk of gas and planetesimals still surrounding the young Sun. As it moved inward, it disrupted the orbits of countless icy bodies that had formed in the region we now call the Kuiper belt. Some of these bodies were scattered outward, ejected into the outer darkness. Others were thrown toward the inner solar system, where they would, billions of years later, deliver the water and organic molecules that made life possible on Earth. Then, around the time Jupiter had traveled about as far as Mars's current orbit, something shifted. The giant planet's gravity began to interact with Saturn in a new way. Jupiter was pulled back outward, and Saturn followed. This dance, this tack, as astronomers call it, happened not in hours or days but across millions of years, a rhythm so slow that by human standards it would be invisible, a glacier-like migration of the solar system's architecture. And in the wake of this migration, left behind in the distant regions beyond Neptune's orbit, was a collection of icy bodies that had been largely untouched, largely unheated, largely unchanged since the solar system's infancy. The Kuiper belt, in this model, is a memory. It is the frozen remainder of what the outer solar nebula left behind once the great planets had finished their long journey to their current positions. The bodies in this belt are, in a very real sense, fossils, not fossils of life, but fossils of planetary formation itself. They retain within their ice and rock the chemical composition, the isotopic signatures, the ancient volatiles that were present in the solar nebula 4.5 billion years ago. When we study methane frost on Pluto's surface or nitrogen ice on other dwarf planets, we are holding in our instruments a direct sample of the solar system's childhood. We are reading a record written in frozen chemistry. This stability, this calm preservation, is what makes the Kuiper belt so profoundly peaceful. The bodies there orbit at tremendous distances from the Sun, but they also orbit at tremendous distances from each other. They do not frequently collide. They do not heat up from internal radioactivity the way the rocky inner planets do. They simply exist, in their cold orbits, changing hardly at all across billions of years. A dwarf planet in the Kuiper belt today is almost certainly very similar to what it was when the solar system was young. The ice on its surface has barely thawed. The rocks have barely shifted. It is, in essence, at rest. Scientists believe, and this is a working hypothesis supported by a growing body of evidence, that the primordial Kuiper belt was far denser than it is today. There may have been thousands of icy bodies, some perhaps as large as Earth or larger, scattered throughout the region. Over eons, gravitational interactions with Neptune and with each other gradually scattered many of these bodies into the outer reaches of space or back toward the inner solar system. The belt we observe now is a sparse remnant, a diluted echo of what once was. And yet what remains is still vast beyond easy comprehension, still full of worlds we are only just beginning to know. The formation of the Kuiper belt reminds us that the solar system was not created in its current form, as if by an instant hand, but rather emerged through a long process of becoming. Planets moved, asteroids drifted. The architecture of our cosmic neighborhood shifted and settled like a structure finding its foundation. And when the movement finally ceased, when the planets found their resonances with one another and locked into their current orbital patterns, the Kuiper belt was left behind, a quiet testament to a more chaotic time, a frozen archive of creation. And yet, as we contemplate these frozen worlds turning through the void, a peculiar humility settles in, the recognition that human awareness of the Kuiper belt is, in the most literal sense, vanishingly brief. For billions of years, this realm of ice existed in absolute silence, unobserved, unmeasured, entirely indifferent to whether any conscious mind knew of its presence. The belt was there before writing, before cities, before the first human lifted their gaze to wonder at the stars. It will remain there, slow and patient, long after we have become dust. Consider the timeline with a kind of gentle arithmetic. The Kuiper belt has existed for perhaps 4.5 billion years. Human civilization, from its first settlements to this present moment, spans maybe 10,000 years. That means the belt has endured for roughly 450,000 times the entire arc of human culture. And our instruments, our spacecraft, our telescopes, our conscious study of this region, we have been looking outward with any real clarity for mere centuries. New Horizons took 9.5 years to reach Pluto. It will take another 300 years or so just to escape the gravitational embrace of the Sun entirely. By then, the belt will have moved through its slow gravitational rhythms unchanged, indifferent to our fleeting observation. What does this mean, in the quiet hours when such thoughts arise? Perhaps it means that the Kuiper belt has a permanence that feels almost restorative to contemplate. Everything we see there, every dwarf planet spinning in its ancient path, every comet beginning its long drift inward, every particle of methane ice suspended in its orbit, has been doing these things for incomprehensibly long stretches of time. Pluto, which we reclassified and reassigned and debated so recently, has been serenely completing its journey around the Sun every 248 years, asking no permission, seeking no approval. It simply continues. The countless icy bodies orbiting in the dimness beyond, some of which we have named and some of which remain unnamed, undiscovered, unknown, move through their paths with a constancy that precedes us and will outlast us. Our brief moment of observation, this handful of decades in which we have turned instruments toward the belt and received back the first true images, the first close measurements, the first genuine glimpses. This is like a single breath in the life of something immeasurably ancient. When New Horizons captured those images of Pluto in 2015, it was the first time any human technology had ever seen that world close enough to distinguish surface features. But Pluto itself had already completed its slow orbit for the better part of its existence without any observers at all. The icy cliffs of Sputnik Planitia stood as they stood, the smooth nitrogen plains stretched as they stretched, and not a single photon of reflected sunlight reached an instrument designed to receive it. The beauty was always there, the geometry was always there, the complex ice chemistry, the thin haze of methane, the shadows and lights, all of it was always unfolding in that distant dark. This perspective, held gently in mind as sleep approaches, carries something unexpectedly soothing. We live in an age of acceleration, of constant documentation, of the feeling that if something is not captured and shared in real time, it does not fully exist. But the Kuiper belt teaches a different lesson through its simple, unhurried presence. Things continue, orbits complete themselves. Worlds hold their ground, or more accurately, hold their trajectories, regardless of whether anyone is watching. For untold eons, the belt thrummed with its own slow gravitational music, moving through the darkness in patterns so enormous and so gradual that to call them motion at all seems almost to distort the word. They simply were, and are, and will be. When we imagine the New Horizons spacecraft still drifting outward, still transmitting its data back across the solar system at the speed of light, still falling through the void toward that unmapped frontier beyond Neptune's influence, we are imagining a kind of grace note in a symphony that will continue without end. The spacecraft is there because of human ingenuity, human curiosity, the particular burning questions that arise in minds like ours. But the belt itself requires no such justification. It needs no observer to complete its existence. It is already whole, already perfect in its ancient way, already at rest. And perhaps that is what draws us to study it, even as we sleep, even as our minds drift toward the place where consciousness fades and dreams begin. We are reaching towards something that precedes us, something that will endure beyond us, something fundamentally untouched by the brief urgency of human time. There is a deep restfulness in that reaching, a quiet acceptance in learning to see ourselves as brief witnesses to a permanence that does not require our witnessing. The Kuiper belt does not lean toward us. We lean toward it, and in that leaning, in that gentle extension of curiosity across the vast distances, we find ourselves settling into a rhythm that matches not the pulse of human life, but the infinitely slower heartbeat of the cosmos itself. Everything continues, everything waits, everything in the end is still. And so we find ourselves, at the end of this long journey outward, standing at the threshold of a realm that will remain largely unknowable to us in our lifetime, a frontier of ice and silence that stretches so far beyond our reach that even light takes hours to carry messages back to those who are listening. The Kuiper belt does not demand our attention. It does not announce itself. It simply exists, has existed for billions of years, and will continue to exist long after we are gone, turning slowly in the dark, patient and indifferent and utterly at rest. There is something deeply settling about contemplating a place so far away, so removed from the chaos and noise of our daily lives. The belt orbits in a realm where the sun is no longer a warmth but merely a distant, aging star, where the concept of day and night has lost all meaning. The dwarf planets and icy bodies there know nothing of seasons as we understand them, nothing of the frantic pace of life on the third planet inward. They move through space on paths so large and slow that a single orbit might take 300 years, or 500, or more. Somewhere out there, a chunk of primordial ice is completing a journey it began when dinosaurs walked the Earth, when humans were not yet even a thought in the universe's vast imagination. What a profound luxury that must be, we might wonder, to move through time so slowly, to have such unimaginable patience. The Kuiper belt contains no rush, no pressure, no urgency. Every moon orbits its parent body in a dance that has been choreographed by gravity alone, and gravity never hurries. Gravity knows only patience. Gravity understands that time is infinite, and there is no need to move quickly when you have forever. In a way, to think about the Kuiper belt is to think about what true stillness might feel like, what true rest might mean when stretched across billions of miles and billions of years. Consider the silence that fills that region of space. It is not the silence of a quiet room, which is never truly silent. There are always the small sounds of air moving, of distant traffic, of the hum of electricity, and the beating of our own hearts. No, the silence of the Kuiper belt is the silence of a near-perfect vacuum, broken only occasionally by the gentle whisper of solar wind, by radiation that has traveled for so long that it has become almost nothing at all. It is the silence of a place where sound itself cannot travel, where no creature has ever heard a sound, where the only movements are the slow, stately motions of ancient bodies following paths they have followed for eons. To imagine such silence is to imagine peace at its most profound. And the cold. We spoke of the cold earlier, but let us sit with it once more as we near the end of our journey. The Kuiper belt is so cold that our minds cannot fully grasp it. We can imagine winter, we can remember standing in snow, we can feel the bite of frost on skin, but the Kuiper belt is colder than any place any human has ever been or could ever go. Colder than Antarctica, colder than the top of Mount Everest, colder than the deepest winter night in the Arctic, so cold that gases become solids, that water ice does not melt but only sublimes, turning directly into vapor when warmed by the faintest touch of distant sunlight. This cold has preserved these icy bodies almost perfectly, holding them in an ancient sleep, unchanged since they first formed in the solar nebula billions of years ago. There is comfort in this immutability, in this unchanging nature. In our world, everything moves and shifts and changes. Seasons turn, landscapes are reshaped, species evolve. But the Kuiper belt stands as a kind of cosmic monument to stillness, a frozen archive of the solar system's childhood, protected by distance and cold from the chaos of the inner worlds. Pluto rests there, in its slow orbit. Eris drifts through the darkness. Makemake and Haumea, and thousands of other worlds, each unique, each strange and beautiful in its own way, continue their ancient rounds, undisturbed and undisturbing. When we gaze outward and think about such a place, what are we really thinking about? Perhaps we are thinking about escape, about the possibility of such distance, such separation. Perhaps we are allowing our minds to travel to a place so far from the concerns of daily life that for a moment, those concerns cease to matter. The bills do not reach the Kuiper belt. The worries do not travel there. The urgent emails and the demands of the day are all confined to the inner solar system, kept away by billions of miles of empty space. Out there, nothing is urgent. Nothing has changed in any significant way since before humans existed. Nothing will change for millions of years to come. There is a strange freedom in that thought, is there not? And perhaps that is why the Kuiper belt calls to us in these quiet moments, in the hours before sleep when our minds begin to soften and drift. It represents, in some sense, a kind of ultimate rest, a place where motion is so slow it might as well be stillness, a place where time moves so gently that it hardly seems to move at all, a place so far away that it feels less like a part of our solar system and more like another universe entirely, one where the laws of urgency and haste have never applied and never will. The New Horizons spacecraft, as we mentioned, is continuing outward still, drifting deeper and deeper into this realm. Each day it moves farther from home. Each day it grows more silent, more distant. Eventually, it will fade beyond the reach of our signals, and it will continue on, a tiny messenger from a small blue world, carrying within it the voices and images of those who sent it forth. And long after it stops sending messages, long after the humans who built it have turned to dust, the spacecraft will continue its slow journey outward, out toward the very edge of the Kuiper belt, out toward the Oort cloud and the true darkness beyond. In the meantime, the belt itself continues its patient work, its slow rotation, its timeless vigil over the solar system's oldest memories. The ice worlds orbit in their ancient patterns. The dust and debris drift in their slow currents. The deep cold preserves everything, changes nothing, asks nothing of the universe but to be left alone in its quietude. And as we drift towards sleep, as our minds begin to settle into their own kind of stillness, we might imagine ourselves out there, far from the noise and light of the inner worlds, in a place where silence is profound, and rest is eternal, and time moves so slowly that it has almost stopped moving altogether. We might imagine ourselves among those ancient, icy, sleeping bodies, orbiting slowly through the dark, at peace, at rest, undisturbed and undisturbing, for now and for always.